January 23, 1855, Ogden, Utah Territory. In a frontier workshop where the smell of gun oil mingles with sawdust and the ring of hammers on metal echoes through thin wooden walls, a child is born into a world of firearms and mechanical precision. His father, Jonathan Browning, is a gunsmith of considerable skill, a Mormon pioneer who crossed the plains with Brigham Young's company, a man whose hands know the language of springs and triggers and firing pins. The child, named John Moses Browning, enters a world where survival depends on reliable weapons, where a malfunctioning rifle can mean death on the frontier, where the gap between excellent craftsmanship and mediocre work is measured in lives saved or lost. Jonathan's workshop becomes the boy's classroom, his playground, his university. By age 10, John Moses Browning can disassemble and reassemble firearms blindfolded. By age 13, he has designed and built his first gun from scrap metal found in his father's shop, a single-shot rifle whose firing mechanism demonstrates principles that will later appear in patents recognized worldwide. No one watching this frontier boy, this son of an immigrant gunsmith working in territorial obscurity, could possibly imagine that his designs will one day arm the greatest military forces in human history, that his inventions will help decide the outcome of 2 world wars, that a single weapon he conceives will save the lives of 50,000 bomber crew members and give America and her allies the priceless gift of air superiority. The story of how an impossible machine gun transformed aerial warfare and saved tens of thousands of lives begins, not with metal and gunpowder, but with a peculiar genius, the ability to think in 3 dimensions, to visualize mechanical systems as complete working entities without blueprints or engineering diagrams. John Moses Browning possesses this gift from childhood, refining it through decades of obsessive work in gunsmithing. Where other inventors laboriously sketch designs and calculate tolerances, Browning simply sees the complete mechanism in his mind, understands how each component interacts with every other component, knows instinctively which dimensions must be precise and which can vary without affecting function. He works from mental images translated directly into metal through his own hands or the hands of his brothers Matthew and Edward, who become his manufacturing partners. The workshop in Ogden produces firearms that achieve commercial success beginning in the 1880s, when Winchester Repeating Arms Company purchases Browning's patent for a single-shot rifle and begins a relationship that will last decades. Browning designs lever-action rifles, pump-action shotguns, semi-automatic pistols, each one representing a breakthrough in its category, each one setting new standards that competitors struggle to match. But it is machine guns, weapons capable of sustained automatic fire, that become Browning's most consequential innovation. His first gas-operated machine gun, the Colt Browning Model 1895, introduces a principle that will dominate machine gun design for the next century, using expanding gases from fired cartridges to cycle the action automatically. The innovation surpasses the recoil-operated systems used by competing designs, proving more reliable and more adaptable to different calibers and applications. The U.S. military adopts Browning's water-cooled M1917 machine gun during World War I, arming American infantry with a weapon that proves devastatingly effective in the static trench warfare that characterizes that conflict. Browning's automatic rifle, the BAR, becomes standard issue for American infantry, providing squad-level automatic fire that gives American units tactical advantages over enemies armed with bolt-action rifles. By 1918, John Moses Browning has established himself as America's preeminent firearms designer, the man to whom the military turns when innovation is required, when existing weapons prove inadequate, when new threats demand new solutions. July 1917. General John J. Pershing, commanding American Expeditionary Forces in France, sends an urgent request to U.S. Army Ordnance. The request is straightforward but technically daunting. Develop a heavy machine gun capable of penetrating armor and destroying aircraft. The Germans have introduced armored vehicles and observation aircraft that are invulnerable to standard rifle caliber ammunition. American forces need a weapon that can defeat armor at range, that can bring down aircraft before they complete reconnaissance missions, that can provide defensive firepower against mechanized threats. The specifications are precise. The weapon must fire a projectile at 2,700 feet per second, must penetrate 3/4 of an inch of armor plate at 600 yards, must achieve a high rate of fire, must be reliable under combat conditions. Army ordnance officers studying these requirements recognize immediately that no existing weapon meets these criteria. The ammunition itself does not exist. Creating a machine gun to fire ammunition that has not yet been designed presents extraordinary challenges. Ordnance officers consult John Moses Browning, who is then 62 years old, already a legend in firearms design, already the inventor of weapons that have transformed American military capability. Browning reads the specifications carefully, considers the problem from every angle, then responds with characteristic directness. Well, the cartridge sounds pretty good to start. You make up some cartridges and we'll do some shooting. The response captures Browning's approach perfectly. Practical, focused on results rather than theory. Confident that if ammunition can be manufactured to specification, he can design a weapon to fire it effectively. Winchester receives a contract to develop the cartridge. Engineers at Winchester work alongside Frankfurt Arsenal to create what will become the 50 BMG, Browning machine gun cartridge, a massive round measuring 12.7 millimeters in diameter and 99 millimeters in length, capable of delivering enormous energy at long ranges. The cartridge dwarfs the standard .30 R06 rifle round used by American infantry. A single 50 BMG round weighs more than 3 .30 R06 rounds combined. The projectile, traveling at 2,700 feet per second, carries sufficient energy to penetrate armor, destroy engines, and bring down aircraft with single hits. With the cartridge under development, Browning turns his attention to designing the weapon itself. He begins with his earlier M1917 machine gun design, scaling up components to handle the increased pressures and recoil forces generated by the massive 50 BMG cartridge. The weapon must be robust enough to fire continuously without mechanical failure, must dissipate heat generated by sustained firing, must remain accurate despite recoil forces that would destroy lighter designs. Browning works in partnership with Colt, which will manufacture the weapon once the design is finalized. Prototypes are fabricated, tested, modified, tested again. Each iteration reveals problems requiring solution. Feed mechanisms jam, barrels overheat, recoil springs fail under stress. Browning addresses each problem systematically, redesigning components until the weapon functions reliably under all conditions. By November 1918, prototypes are ready for military testing. The date of completion carries bitter irony. November 11, 1918, Armistice Day, the day World War I ends. The weapon designed to defeat German armor and aircraft arrives too late to see combat in the war that prompted its creation. The war's end does not eliminate the need for heavy machine guns. Post-war military planners recognize that future conflicts will involve armored vehicles, aircraft, and mechanized forces in numbers that dwarf World War I deployments. The United States needs weapons capable of engaging these threats. Testing continues through the early 1920s. The initial water-cooled design, designated M1921, proves effective for fixed defensive positions, anti-aircraft emplacements, and shipboard installations where the weight of water cooling systems is not prohibitive. But infantry commanders need portable weapons, need machine guns that can be moved rapidly across battlefields, need designs that do not require carrying heavy water reservoirs. Browning addresses this requirement by developing an air-cooled variant with a heavy barrel capable of dissipating heat through natural convection, rather than water cooling. The redesigned weapon, designated M2HB, heavy barrel, achieves official military adoption in 1933, 7 years after Browning's death in 1926. John Moses Browning never witnesses the full impact of his most consequential military innovation. He dies in Belgium, at the Fabrique Nationale factory in Herstal, where he has traveled to oversee development of a new over and under shotgun design. He collapses at his workbench and dies within hours, age 71. His life consumed by work that has already transformed warfare and will continue transforming it for generations beyond his death. The M2 machine gun enters American military service quietly, initially deployed in limited numbers for specialized roles. Few recognize that this weapon will become the longest-serving firearm in American military history, that it will remain in continuous service for over a century, that it will arm virtually every American combat aircraft during World War II, that it will prove decisive in air battles that determine the outcome of history's greatest conflict. During the 1930s, as tensions rise in Europe and Asia, as Nazi Germany remilitarizes and Imperial Japan pursues expansion through conquest, American aircraft designers grapple with the problem of defensive armament for bombers. Aircraft like the B-17 Flying Fortress, Conceived in the mid-1930s as strategic bombers capable of reaching enemy industrial centers, require defensive guns to protect against fighter attacks. Early bomber designs mount inadequate armament. 4 or 5 machine guns firing rifle-caliber ammunition, insufficient to deter determined fighter attacks. Combat experience in the Spanish Civil War and early World War II battles demonstrates conclusively that bombers without adequate defensive armament suffer catastrophic losses when attacked by modern fighters. Boeing, manufacturer of the B-17, receives urgent feedback from RAF crews operating early Flying Fortress variants in 1941. The feedback is unambiguous. The aircraft needs more guns, heavier guns, guns positioned to cover every approach angle, guns capable of damaging or destroying attacking fighters before they close to lethal range. Boeing engineers study the problem systematically, analyzing angles of attack, fields of fire, ammunition supply requirements. They conclude that the Browning 50 caliber M2, adapted for aircraft use, provides the optimal solution. The aircraft variant, designated AN-M2, features modifications specific to aerial application, lighter components where possible, ammunition feed systems designed for reliability during high-G maneuvers, mounting systems compatible with power turrets and flexible gun positions. The B-17E model, introduced in 1941 following Pearl Harbor, mounts 10-50 caliber Browning machine guns in defensive positions covering every approach except directly ahead. The B-17F increases armament to 11 guns. The final B-17G variant, recognizing that German fighters have adapted tactics to attack from the nose where early models lack armament, mounts 13 50 caliber Brownings, twin guns in a chin turret, twin guns in dorsal and ball turrets, twin guns in the tail position, single guns at waist positions, cheek positions, and radio operator station. The transformation of the B-17 from inadequately armed bomber to Flying Fortress bristling with defensive firepower represents a vindication of Browning's original design philosophy. The 50 caliber. Browning possesses characteristics that make it ideal for aircraft defense. It fires heavy projectiles capable of damaging or destroying fighter aircraft with a few hits. It achieves high muzzle velocity, giving projectiles flat trajectories and long effective ranges. The rate of fire, approximately 800 rounds per minute in the aircraft variant, allows gunners to track moving targets and adjust aim based on tracer observation. The weapon proves extraordinarily reliable, functioning in conditions of extreme cold at high altitude, tolerating the vibration and G-forces of combat maneuvering, rarely jamming despite dust, moisture, and inadequate maintenance. Most importantly, the effective range of the 50 caliber Browning exceeds the range of German fighter armament in the early war period. German fighters armed with 7.92 mm MG-17 machine guns must close to within 400-500 yards to achieve effective hits. American bomber gunners equipped with 50 caliber Brownings can engage targets at ranges exceeding 1,000 yards, forcing German fighters to endure defensive fire throughout their approach runs. The strategic bombing campaign against Nazi Germany, beginning in earnest in 1942 and continuing through 1945, subjects the B-17 and its 50 caliber defensive armament to the most severe test imaginable. American doctrine calls for daylight precision bombing, attacking specific industrial targets in clear weather using visual bomb sights, flying in massive formations at altitudes between 20,000 and 30,000 feet, proceeding directly to targets despite fighter opposition and anti-aircraft fire. The doctrine assumes that bombers in tight formations, each armed with numerous 50 caliber machine guns providing interlocking fields of fire, can defend themselves adequately against fighter attacks without requiring escort fighters. The assumption proves tragically optimistic. German fighters, initially caught off guard by the scale and determination of American bombing attacks, rapidly adapt their tactics. Luftwaffe fighter pilots discover that attacking B-17 formations from the rear, where American tail gunners man twin 50 caliber Brownings, results in heavy casualties. German pilots describe the experience of approaching B-17 formations from behind in terms that convey both respect and dread. One pilot reports that attacking a combat box formation from the rear is like trying to make love to a porcupine that is on fire, an image capturing both the density of defensive fire and the suicidal nature of rear attacks against alerted bombers. German fighters adapt by adopting frontal attacks, diving from high altitude directly toward bomber formations, engaging at high closing speeds that minimize exposure time to defensive fire. The tactic proves devastatingly effective against early B-17 models lacking forward-firing armament. German fighters equipped with 20mm cannons and 30mm cannons open fire at ranges of 1,000 yards, closing rapidly while firing continuously. Breaking away just before collision, their attacks time to exploit the brief period when bomber pilots must maintain straight and level flight during bomb runs. American bomber losses mount to unsustainable levels. The raid on Schweinfurt in October 1943 cost 60 B-17s destroyed out of 291 dispatched, a loss rate of 19% in a single mission. If sustained, such losses would eliminate entire bomb groups in weeks. The crisis forces recognition that bombers, despite their 50 caliber defensive armament, cannot survive deep penetration missions without fighter escort. Yet the 50 caliber Browning proves its worth even in these desperate circumstances. Defensive fire from B-17 formations accounts for hundreds of German fighters destroyed, thousands more damaged. Luftwaffe fighter pilots interviewed after the war consistently cite American 50 caliber defensive fire as a primary threat, describing the psychological impact of approaching bomber formations through walls of tracers, knowing that a single hit could prove fatal. German ace Adolf Galland, one of the Luftwaffe's most experienced and successful fighter pilots, emphasizes in post-war testimony that maintaining formation discipline under defensive fire represents the critical challenge for German fighter pilots attacking B-17 formations. The Browning 50 caliber does not prevent German fighters from attacking, but it forces them to attack in ways that reduce their effectiveness, that expose them to risks that gradually attrit German fighter strength beyond sustainable levels. The defensive armament buys time for American air forces to develop long-range escort fighters, buys time for bomber crews to learn defensive tactics, buys time for the industrial machine to produce sufficient aircraft to overcome losses. The survival statistics for American bomber crews reveal the brutal arithmetic of aerial warfare in 1943 and 1944. A standard combat tour consists of 25 missions. Crews completing 25 missions without being killed or captured earn rotation home. Only 35% of air crews complete their tours successfully. The remaining 65% are killed, captured, or evacuated due to wounds. The casualty rates vary by crew position, reflecting the different levels of exposure to enemy fire. Bombardiers positioned in the exposed nose section where they operate bomb sites suffer the highest casualty rates, 16.3% killed and 17.7% wounded. Tail gunners, despite their armored position and twin 50 caliber Brownings, suffer 17.3% killed and 12% wounded. Waist gunners, manning single 50 caliber guns at open windows on either side of the fuselage, suffer combined casualty rates exceeding 40% when both positions are counted together. Ball turret gunners suspended beneath the fuselage in spherical Sperry turrets containing twin 50 caliber Brownings suffer lower casualty rates, 6.4% killed and 5.9% wounded, but face other horrors, including the risk of being trapped in their turrets if the aircraft is damaged and the turret mechanisms fail. The psychological toll on gunners is immense. They watch attacking fighters approach through their gun sights, watch as their tracers reach out toward the attackers, sometimes see their fire strike home and watch enemy aircraft explode or spin away trailing smoke. Other times watch helplessly as their tracers fall short or miss while enemy cannon fire tears through their aircraft. They witness crew members killed by enemy fire, watch bombers in their formation explode or fall away trailing smoke, endure hours of freezing cold at altitude where temperatures drop to 50 degrees below 0 Fahrenheit, wear electrically heated flight suits that sometimes malfunction and cause burns, suffer frostbite on exposed skin, breathe oxygen through masks that sometimes ice up and restrict breathing. And they do this repeatedly, mission after mission, knowing that the odds of completing 25 missions are worse than 1 in 3. The 50 caliber Browning becomes their closest companion, their tool for fighting back, their means of imposing cost on attackers, their only agency in situations where they are otherwise helpless passengers awaiting destruction. The arrival of long-range P-51 Mustang escort fighters in late 1943 and early 1944 transforms the strategic situation, but it does not eliminate the importance of bomber defensive armament. Even with fighter escort, German fighters penetrate to bomber formations and press attacks. Even with fighter escort, bomber gunners continue engaging German aircraft and accounting for significant numbers destroyed or damaged. The combination of 50 caliber defensive fire and escort fighters creates a situation where German fighter attacks become prohibitively costly. German pilots must survive both fighter interception and defensive fire to press attacks home, then must survive egress while potentially damaged and low on ammunition. The attrition proves unsustainable. By mid-1944, German fighter losses exceed replacement rates. Experienced pilots are killed and replaced by inadequately trained pilots who lack the skill to survive in aerial combat against veteran American gunners and fighter pilots. The Luftwaffe enters a death spiral from which it never recovers. Post-war analysis attempts to quantify the contribution of bomber defensive armament to overall American victory in the air war over Europe. The analysis is complicated by the difficulty of attributing specific outcomes to specific causes. How many American bomber crew members survived because German fighters were deterred by defensive fire? How many missions succeeded because German fighters declined to press attacks due to defensive armament? How many German fighters were destroyed or damaged by 50 caliber defensive fire? The available data suggests that B-17 and B-24 gunners claimed approximately 6,000 German aircraft destroyed during the strategic bombing campaign. Post-war examination of German records indicates actual losses were significantly lower, perhaps half the claimed total. But even accounting for overclaiming inevitable in the chaos of air combat, bomber defensive armament accounts for the destruction of thousands of German fighters and the damage of thousands more. More importantly, the presence of defensive armament forces German fighters to adopt tactics that reduce their effectiveness and increase their exposure to escort fighters. The conservative estimate proposed by several post-war military historians suggests that 50 caliber defensive armament directly saved approximately 50,000 American bomber crew lives either by destroying or deterring German fighters that would otherwise have shot down bombers, or by enabling bombers to survive damage long enough to reach friendly territory, where crews could bail out or crash land with prospects of survival. The figure represents extrapolation from combat loss rates before and after defensive armament improvements, comparison of loss rates between bombers with different armament levels, and analysis of German fighter pilot testimony regarding the deterrent effect of defensive fire. The methodology is imperfect and the estimate necessarily approximate, but the order of magnitude appears defensible. 50,000 lives saved represents over 5,000 bomber crews, over 400 complete bomb groups worth of personnel, a force larger than the entire air crew, strength of the 8th Air Force at any single point during the war. The calculation underscores the strategic impact of John Moses Browning's most famous military innovation. The 50 caliber M2 machine gun, conceived in response to World War I requirements for anti-armor and anti-aircraft weapons, adapted for aircraft use during the interwar period, and deployed en masse on American bombers during World War II, proves to be one of the war's most consequential weapons. It does not win the air war alone. Victory requires strategic bombing doctrine, industrial capacity to build bombers by the thousands, trained air crews by the tens of thousands, escort fighters to neutralize German fighters, logistical systems to sustain operations over years of sustained combat. But the 50 caliber Browning provides the foundation for bomber defense, the basic capability without which strategic bombing would have been impossible, the minimum force necessary to give bomber crews a fighting chance against determined fighter opposition. The M2's versatility extends beyond bomber defense. American fighter aircraft P-47 Thunderbolts mounting 8 50 caliber Brownings, P-51 Mustangs mounting 6, use Browning machine guns as primary armament, destroying thousands of German aircraft in air-to-air combat, and attacking ground targets with devastating effectiveness. American ground forces use the M2HB heavy barrel variant as infantry support weapons, anti-aircraft weapons, vehicle-mounted weapons. American naval vessels mount M2s for anti-aircraft defense and for engaging surface targets. The weapon proves extraordinarily adaptable, capable of fulfilling multiple roles with minor modifications. The longevity of the M2 design becomes legendary. While other World War II-era weapons are retired and replaced by more modern designs in the decades following the war, the M2 continues serving. It serves in Korea and Vietnam, in the Gulf War, in Iraq and Afghanistan, It remains in service today, over 100 years after John Moses Browning completed the original prototypes. Only the M1911 pistol, also designed by Browning, serves longer in American military service before being replaced by more modern designs. The reasons for the M2's extraordinary longevity trace directly to Browning's design philosophy. The weapon is mechanically simple, using robust components that tolerate abuse and inadequate maintenance. The design does not require tight tolerances or specialized materials. Any competent machine shop can manufacture replacement parts. The weapon can be field stripped and maintained by soldiers with minimal training. The basic operating principle, recoil-operated, belt-fed, air-cooled, proves so fundamentally sound that no subsequent innovation renders it obsolete. Later designers developed machine guns with higher rates of fire, lighter weight, or more advanced features. But none surpasses the M2 in the combination of reliability, power, and versatility that matters most in military service. The 50 BMG cartridge, developed specifically for the M2, becomes a standard around which other weapon systems are designed, creating an installed base that makes replacement economically prohibitive. The United States and allied nations have invested enormous resources in ammunition production facilities, logistics systems, training programs, all built around the 50 BMG cartridge. Changing to a different cartridge would require replacing this entire infrastructure, a cost measured in tens of billions of dollars. John Moses Browning's legacy extends beyond the M2. He designed the M1911 pistol, standard American military sidearm from 1911 to 1985. He designed the M1917 and M1919 machine guns, workhorses of American infantry in both world wars. He designed the Browning automatic rifle, squad-level automatic weapon, that gave American infantry fire superiority over enemies armed with bolt-action rifles. He designed the Auto 5 semi-automatic shotgun, the first commercially successful semi-automatic shotgun, and a design that remains in production over a century after its introduction. He designed firearms for Winchester, Colt, Remington, Stevens, and Fabrique Nationale, contributing directly to their commercial success, while receiving comparatively little public recognition during his lifetime. He accumulated 128 individual firearm mechanism patents, an extraordinary record that positions him among the most prolific inventors in American history. Yet he worked in relative obscurity, known primarily within firearms industry and military procurement circles, rarely receiving public acclaim during his life. The son of an immigrant gunsmith, working from a frontier workshop in Utah Territory, never attended formal engineering school, never earned an engineering degree, never worked within the established centers of American industrial innovation. He learned by doing, by building firearms with his own hands, by iterating designs until they worked reliably, by thinking in 3 dimensions rather than through mathematical equations and engineering diagrams. His lack of formal training, which might have hindered other designers, proved advantageous. Unencumbered by received wisdom about what was possible or impossible, Browning simply designed weapons that worked, ignoring theoretical constraints that limited other designers. When Army Ordnance requested a machine gun capable of firing a cartridge that did not yet exist, Browning's response, "Make up some cartridges and we'll do some shooting," captures his pragmatic, results-oriented approach perfectly. He did not question whether the request was feasible. He did not produce elaborate analyses proving or disproving possibility. He simply proceeded to design the weapon, confident that if ammunition could be produced, he could design a gun to fire it effectively. The immigrant heritage that shaped Browning's life, son of a Mormon pioneer, raised in a frontier territory where self-reliance was not optional but mandatory, influenced his approach to design and manufacturing. Frontier conditions demand practicality, demand weapons that function reliably without specialized maintenance, demand solutions that can be implemented with limited resources. Browning internalized these requirements, designing firearms that emphasized reliability and ease of maintenance over sophistication and complexity. This philosophy, born from necessity on the American frontier, proved ideally suited for military applications where weapons must function reliably under adverse conditions, must be maintained by soldiers with limited training, must continue operating despite abuse, neglect, and battlefield damage. The M2 embodies this philosophy completely. It is not the most sophisticated machine gun ever designed. Later designs achieve higher rates of fire, lighter weight, more advanced features. But no design surpasses the M2 in the characteristics that matter most for military service: reliability, durability, versatility, ease of maintenance. Epilogue. The workshop in Ogden, Utah, where John Moses Browning crafted his first firearm at age 13 no longer exists, replaced by modern structures that bear no trace of the gunsmith's shop where America's greatest firearms designer learned his craft. Jonathan Browning's original workshop, where the frontier gunsmith taught his son the principles of mechanical design and precise manufacturing, survives only in historical records and museum displays. John Moses Browning himself rests in Ogden City Cemetery, his grave marked by a simple monument that offers no indication of the profound impact his designs had on world history. Few visitors to Ogden recognize the city's claim to fame as the birthplace and home of the man who armed America and her allies during their greatest conflicts. Yet Browning's legacy endures in the continuing service of his designs. The M2, 50 caliber machine gun, conceived in response to World War I requirements and perfected during the interwar period, remains in service today, over 100 years after its initial development. American forces fighting in Afghanistan and Iraq carry M2s essentially unchanged from the weapons that armed B-17 gunners in 1944. The design has been refined, improved in minor ways, adapted for mounting on modern vehicles and aircraft. But the basic mechanism John Moses Browning conceived in the workshop in Ogden remains fundamentally unchanged. The impossible machine gun, the weapon that one man designed in response to General Pershing's urgent request, the heavy machine gun that enabled American bombers to defend themselves against determined fighter attacks, the weapon that conservative estimates suggest saved 50,000 American bomber crew lives during World War II, continues serving America and Allied forces today. It has become the longest-serving firearm in American military history, the weapon that defines the concept of reliability in military service, the standard against which all other machine guns are measured. John Moses Browning, the immigrant, gunsmith's son who began making firearms at age 13 in a frontier workshop, created something that transcends the material reality of metal and gunpowder. He created an idea made manifest. The idea that excellent design, simple enough to be manufactured by any competent machine shop and robust enough to survive abuse and neglect, will outlast more sophisticated designs that prioritize innovation over reliability. The M2 proves that idea correct every day it remains in service. Every time it fires reliably in conditions that would destroy lesser weapons. Every time it saves the life of a soldier who depends on it. The legacy of John Moses Browning, measured in patents and production numbers and decades of continuous service, ultimately comes down to this. He designed weapons that worked when they were needed most, weapons that gave America and her allies the tools necessary to prevail in their greatest trials, weapons that saved lives by the tens of thousands. The 50 caliber M2 machine gun, his most enduring military innovation, stands as permanent testimony to the genius of the immigrant gunsmith's son who changed the world from a workshop in Utah territory